Hello, I'm Smurfawaz, and I just discovered another industry problem. I mean, it's not an industry problem, but it is a general problem faced by Windows and Linux users. So, mostly Windows users have to be specific. So, I'm gonna talk about something called the reverse shell, right? So, reverse shell is something like you get access to another computer. For an example, we call it a victim computer or a target computer, where you can run commands, in the sense PowerShell commands, and just command line commands. So you can just basically do anything you want by having that type of power and access to uh, the target computer. So it's something like, now from my local host, I'm just going through this command prompt and I'm saying, uh, who am I? So now this will tell about my name and stuff like that. So what if I can do more? For an example, if I say directory, so I get all the files here, so I can just manipulate the files, so I can download files, I can do different types of things here. So that that can be very dangerous. So basically, an attacker, he uses a metapredator exploit, right, where he has a payload that you are tricked to run in your computer, in your local device, and that payload will create a connection with the attacker, and the attacker can remotely execute shell commands into your computer. So just like I showed, so basically whatever the commands that I was typing in my local host can be executed in my computer from another device that is connected over the internet. Can be TCP, HTTP, and there are different types of payloads and different type of attacks. So if you ask me, most of these attacks will be detected by the Windows Defender and some other antivirus tools, but not always. So these antivirus tools and Windows Defender, they just analyze a certain file or an exe file through a huge database where they have already common signatures of file types, common signatures of files of that type. So they just compare and tell, okay, this is something that is not good, so this is something fishy. So that's how they detect it. But trust me, payloads can be really unique, and it can vary from attacker to attacker. So I don't want to go deep into how we are going to design a payload, because that's not what we're going to do here. So even if our device is compromised and an attacker has remote access to our computer, so the most valuable things that we have in our computer is our files, right? So what they basically do is, now if your files are it is in a normal format, then he can just view the file from his computer. He can download the file from his computer. So if it's really personal and if it's really private, so if it's in the normal reading format, then the attacker can just look at what is there in the file and things like that. But what if we can encrypt the files? In the sense, as we know, a ransomware attack, where attacker infects a virus, a ransom file into your computer, and he runs that file, and all of your data is getting encrypted. All the files basically are getting encrypted, so you can't see anything. It's just in 1 zeros or in special symbols and characters. So what if we can follow the same technique, right? We're encrypting our files so that even if our system is compromised, the attacker cannot see the real format of the file. So for an example, we are using their same technique in order to protect the most valuable files that we have in our computer. So this is called encryption, right? So we are trying to encrypt something. There are different types of encryption methods, like we have asymmetric and symmetric. So that is a different topic. So I don't want to go into encryption as well in this video. I just want to talk about how we can use the techniques used by hacker. I wouldn't say hacker, but actually how can we use encryption methods to protect our files. So even if you are compromised, they can't see the real format of the file, which is safe. So even if the data is being if it's under theft or something like that, so that will not become a problem. So because they can't see the real version of the file, so there can be sensitive data and stuff like that. So what I've done is I have developed an application, right? So I've used Java and JavaFX and MongoDB here. So I'll tell you why I have used MongoDB. And Now I'll deploy the application. I'll just show you a demonstration. So I'm gonna go into a folder, and if you say locker testing here, so if I just click on this, so whatever it is there in my file is just in the readable form, it's my name. And even if you open the picture here, so it is in really readable form, and I have a PDF here, so when that PDF is in a readable form. So now what I'm going to do is I'm going to encrypt all these files so that only I can access them. So only with my encryption key these files will be in the normal reading format. So I'm going to show that. So I'm going to deploy my application. Some time, and good. So this is the MongoDB connection and the MongoDB related messages. So it's being printed on my console, and now I have created it's my onboarding, so I have not created a user yet. So this is the main gateway to the application. So I'm gonna give that a username. So I'm gonna use Chucks because I use Chucks for all my anonymous activities. I'm gonna use a simple password, and the password range is being limited, so it is there's a maximum number of characters can be 10, so I'm just going to give a very simple password. So when I click on TrickTalker, so it is going to compare this password, and it says user created Chucks, and close. So I have to now sign in. That's basically the same stage and the scene, but I have hide the objects that I don't want to using a database fetch from my MongoDB. So now I'm going to say the password, say authenticate, bring granted access into a locker, and now I'm in my dashboard. So you can see it is very simple here. It's my username here and the first letter of my name. So this is for logging out. I'm going to log out for now. So I'm going to Explorer. I'm going to navigate into the folder that I just said, so locker testing. What I'm going to do is I'm just going to encrypt this folder. So I'm going to say encrypt. Okay, so it's saying the locker testing was successfully encrypted and protected. Okay, so I'm going to click on OK. So if I just return now, if I just try to look at these, okay, so now this is not in the most readable form. You can see that. So it is like, something that nobody understands. And even if I go into the screenshot that I had, so it's going to be much more complex to read and understand. So it's taking some time to load. So I think it's Chinese. So the encryption method and type I've used here is AES, which is Advanced Encryption Standard, which was introduced by the USA. And so that's the power of encryption. Now even if an attacker compromises my system, and if he just tries to view this file, this is all he will get. So without the unique decryption key, he cannot decrypt the file. So I will talk about the technique that I've used to encrypt the file. And if I try to open this PDF, it's going to be the same. It's just like, nobody understands what it is. This is called cryptography. So it's all encrypted. And now going to go back into my application, I'm going to say decrypt. Just going, okay, is under your supervision. Okay, so now everything is back to its normal form. So if it can be only decrypted with the same key that I've used for encryption. So here I'm gonna close this. So now what I'm gonna do is I've used the authenticate. So I've used MongoDB here. So I have used a very simple technique to write to the database. So now you saw that I used the same stage and screen. So I'm saying the user check. So I have a iterator, a find iterator, and a document, so a collection. So how MongoDB works is very interesting. It is very easy and straightforward than SQL databases. So SQL databases have structured query language for querying, and you have a certain set of fields and records that have a structure. But when it comes to MongoDB, you just have a database right here, and everything inside that is just in document form, and you have a collection called user credentials. So inside that you are going to have something like this. So these are gonna be keys and these are gonna be values. So in my application here, so after the user check I'm doing the authenticate thing. So for that, down here I have the user creation. If you look at my user creation, I call document user is equal to new documents. I'm creating a new document inside my collection, and you can see that I have specified the key and the value here. So I've got the text username dot get text, so that is getting the text inside the object, so which is the username, and same to the password and a username and password as well. So this is going to be the unique name of the file, and these are going to be the keys inside it. So if you look at collection, so I've initialized a variable here called collection. So this is how I've imported all my Mongo client and stuff like that. So I had some conflicts in getting this done because I'm using Maven. And then if you look at my code here, so I've got collection here, so it's a document, so it's a Mongo collection, so it is a document, so I'm getting it to the object here. So I have a DB object here, so Mongo database, so that is referring to the database's name, and this is the port and the host name, and this is the credit, the collection's name. So even my password that is going into the database is encrypted here. So you can see it is not in readable form. So these are industry best practices that I've used to make sure that even if the database is snatched from the system through some technique or manipulation, so the attacker cannot see the real password. So that is really safe. So this is going to be really encrypted. And even if you come to the authentication, right? So I'm looking for some null values here. So if it is empty and stuff like that, or it doesn't match or anything like that, so it is empty. So I'm looking for null text boxes. So if it's null, so it's not going to proceed. It's going to throw you error messages saying to get these things done. So now I'm going to just show you that. So how I have used error handling here. So error handling from the GUI level. So now I have not typed anything in my username and password, so I'm going to say authenticate. So it's going to say username or password is incorrect or missing. So I'm going to give some random thing here and just going to trying to authenticate. So it's going to say the same error. So we don't want to give very precise and meaningful answers saying that, oh, your username is not right or your password is not right. So we just want to give a general message, so that the attacker does somebody who is trying to trying to access your files is just trying certain random passwords and usernames, so he doesn't get hold of anything. So I'm going to say okay, I'm just going to close it. And if it's not the case, and if you find an iterable document, so inside the collection, if you find something like that, and we have the Mongo cursor, in SQL we have prepared statements and we have results. So prepared that is a different thing where we are using for querying over things, and we are just executing certain commands. So then what we're doing, we are just like in SQL, we are just going to say cursor.hasNext. So if there is something that is similar to what we are looking for, and we are getting the DB username and password. So now we are getting the document here, and the cursor is going through, and by the get string method we are getting the username and password. So these are the keys that are inside the database. And then what happens is I'm giving those passwords outside my while loop, so you can't access. So I don't want all of this to run inside a while loop, so I wanted to take it out. So now I've taken that out. So I'm saying I'm initializing a new string object here. I'm saying entered username, and I'm encrypting it. Even now I'm not decrypting my database password or username. So even in that phase, I don't want to reveal the real actual readable username and password. So those are high industry standard and practical things that we are using. And so I'm trying to encrypt the password that I've got, so I'm encrypting it. So I have a separate method return for encryption here. So I'm using AES encryption, and I have an encryption key up here. So this is my encryption key. So if somebody wants to decrypt my data, he should have the same specific key. So this is not actually a good practice, so specifying your encryption key here. So I don't want to go deep into the industry standards of key management, so they're going to be really complex. So we're going to have a separate key management system or a database where for each and every session we have a custom, unique and a random key generated automatically. So that's what I didn't do that here because this is just a learning purpose, and my purpose is to encrypt files. So that's what I've achieved here throughout my code. And once it is done, so I'm inside my authenticate method. So once it is done, it is granting access to the user, and I'm getting this is also a custom method I have written here, so looking for to show messages with the condition. So you have been granted access to the locker. So this method is also a custom method written by me. So I have the open auth method here that opens the locker authentication.startMyJourney. So once the user has been created, so what I'm doing is I'm giving him the same stage and screen, and I'm hiding certain data from the browser. This is my decrypt method, so I have not used it here. And show method with condition, so this will show a method with condition with okay done method. So what happens is when the user clicks on OK, so it clicks on OK, so what happens is it just closes a certain thing and does something. So even if I want to log out of my system, so it will look for a condition. So it will work based on the condition, because I'm telling just a rough idea about my code. I'm not going in depth and detail. So I'm saying okay, welcome. I just click here. So I say, are you sure, would you like to log out? And there's no and yes. So if I know, I'm saying in the same screen. If I say yes, I'm just signing on. I'm coming back to the same stage, which is the authentication stage. And finally, the code that I wanted to explain is the locker dashboard controller. So how I have used AES encryption here. So what is my logic and what is the secret behind encryption? How did I do that? So it is quite very simple and straightforward. So I have this locker folder method here that throws exceptions. So that is the signature. And if you can just see, it just shows errors. And I have the string folder path search.getText. So you would have seen there's a disabled text field in my application when I just run this. So shucks 1 2 3 4 5 6 and say 1. So this is my search.txt search object here, which I have referred here, which is a text field. So I'm just choosing again, don't want to do anything here. So for testing, so I'm selecting the folder, so that folder name is specified here with the path. And then what happens is looking for file, and I'm creating a file object with the variable name of folder. And then I'm having an if condition that checks if the folder really exists in that specific directory. And if it is yes, so I have another variable here called boolean is already encrypted. So I'm checking whether if the folder is already encrypted. So I'm going to do that. So was successfully encrypted and protected. So now if I just try to encrypt this folder again, if I just click here, it's going to say is already encrypted and it is keeping encryption. So that is another way of my error handling, because I don't want to encrypt the same folder again. So I lose record and it will be encrypted over and over again. So it will get encrypted with the latest version of the file, and that is not going to be the original version when I decrypt it back. So that is a mistake, it's a flaw in the system. So I wanted to prevent that. And then if the file name is there and you say it ends with dot, how the condition really looks for it is it looks for file names with the final extension which ends with dot encrypted. So I'll show you what is happening actually. And then I'm gonna break out of the for loop, and then I'm coming down here and showing the error message saying that it is already encrypted. Else, if those things are not true, I'm going to generate a secret key which is being defined above in my code base. Even this is not a good practice, but for learning purposes it is fine. And I'm gonna just come back down here, and that is my secret key initialized up there, and I'm using safer. So cipher, and I'm using AES and initializing it, and I'm making it to the encrypt mode and the secret key that I've specified here. So now when I'm going down, I'm looking for files and folders, .list files, and if file is a file and if it's available there at location. So I'm having file input streams and file output stream and cipher output stream. So these are three different objects that I'm using throughout my application. So I'm looking for the file. Then what I'm going to do is I'm just going to write into that file. So file output stream. So I'm going to get the file's get absolute path, which is a method, and then I'm going to end it with .encrypted. So I'm creating a basically new file for the actual file. So if it's suma.txt, so for that extension I'm adding .encrypted, so that is completely a new file. And what I'm doing is I'm going to write the cipher output using this object and the cipher as well, so which is going to be the AES, and then I'm writing the byte buffer read, and it is just started to use a while loop to write it to the new file. And then it's saying okay, all of this is happening to the end, to all the files in my folder, including the subfolders as well. So now I'm going to show the message that's saying that it was successfully encrypted and protected, and I'm going to delete the original version of the file. So I don't want an original file there with the encrypted file, so I have only one file, which is the encrypted file. So the vice versa, the reverse of this happened. In the decrypt folder, it looks for the .encrypted, it changes into its original part. So I'm replacing the name here .encrypted, and then I'm decrypting it using my decrypt mode and the secret key. So it will only get decrypted if I have this specific secret key. And that was all for this video actually. So basically I've just introduced something for personal computers that can protect them from attackers. Actually you can't be 100% safe even if your files are getting encrypted. Even if you're encrypted, if you're a victim of one of these attacks like a metapreter exploit, so what a hacker can really do is he can just run some shell commands in your computer, and he can infect a ransomware. And in my upcoming videos I'm planning to work with something called CashCat. So this is a ransom simulation kind of thing. So what we can do is we can just simulate so there are some nice cats, so we can simulate something like a ransomware simulator. So I'll be using some techniques used by hackers to demonstrate that in my upcoming videos. And I'm planning to come up with something that can decrypt and ransomware, so that's gonna be interesting. So thank you so much, and that's all.